Assalamu alaikum dear students. Today's topic is laws of static friction, or we say is limiting friction. In previous classes I have discussed friction and static friction, the limiting friction and the kinetic friction. I have also shown in the graph and make the difference of static friction, limiting friction. I hope you remember the previous lecture. Limiting friction is the maximum value of static friction where the body starts rolling over the surface of the another body. I hope you have remembered that lecture. Before studying the laws of static friction or limiting friction, first of all we should understand what is called normal reaction. Normal reaction. It is usually denoted by R, normal reaction. First of all, we should understand what is normal reaction. Suppose this is the one body 1. I name this body 1. I have placed another body on body 1. This is body 2. That means when I placed another body on body 1, it has applied, body 2 has applied weight or force on body 1. As per rule, it should come down on the ground. But the body 2 does not come on the ground. Why? Because when body 2 applied force on body 1, as per Newton's third law of motion, body 1 applied force, reaction force in the upward direction equal to the weight of the body. That means when body 2 here, it applied a force on body 1, as per rule it should come down. What is the force? That is weight, that is called mg. But on the other hand, body 1, as per Newton's third law, applied a force in the upward direction, and that is reaction force here in the upward direction. That's called a reaction force equal to the weight of body. That's called mg. So that these two forces balanced each other, and when they balance each other, therefore this is called a reaction. That means this reaction force which is applied in the upward direction, the force, that means body 2 is pressed by body 1 with this body 1. That means body 2 plus body 1, but body 2 does not come down. Why it does not come down? Because body 1 creates equal force on body 2. This creates equal force on body 2 called reaction force. This force is created, the force created by reaction by body 2, the force created by reaction by body 1 on body 2 is called normal reaction. This is called a normal reaction. इसको हम normal reaction. Normal reaction क्या क्यों कहते हैं? This is the created by the reaction of body 1 and it is perpendicular. This force is almost equal to 90 degree here, created in the upward direction. That is why it is called a normal reaction. This is called a normal reaction. It is also equal to weight of the body. That means normal reaction. Normal reaction is usually divided by R. If we have to define a normal reaction, then why it's called normal? Because making angle 90 degree. Force of reaction, what is normal reaction? Normal, if we have to define a normal reaction, then normal reaction, or it is the force of reaction. Force of reaction created by the surface, on which the force is applied. The force is applied by another body. रिएक्शन क्यों कहते हैं ये? चूँकि बॉडी 2 इस पे एक्शन डालता है, मतलब फोर्स, when body 2 is applying on the force on it is action force, and on per Newton's third, body 1 is making a reaction in the upward direction, but this is at a 90. It's called normal reaction. That means the force of reaction created by surface on which the force is applied. This force is applied on surface 1. That means force of reaction is created by surface 1 on which the force is applied by another body. This is called a normal reaction. It is usually denoted by R. It is usually denoted by R, where normal reaction is equal to R is equal to mg. It is equal to the weight of the body. Please remember, in plane surfaces, we are discussing here in plane surfaces, R is always equal to mg. You have to remember it. In plane surface, R is equal to R into mg. But in inclined surface here, R is not equal to mg. R उस वक्त mg वो दूसरा case है, that will be studied in the later case. But in plane surfaces, R is always equal to mg. We have to basically, that means this is all about the normal reaction. Basically, we have to study the laws of friction or laws of limiting friction, or you can say laws of static friction. Before this is, that means we have to study the normal reaction, because when we study the laws of friction or laws of limiting friction, we come to the term that is normal reaction. I hope you have got it. Normal reaction. First of all, we study the laws of friction, limiting friction or friction. Number one, there are various laws which are studied. Number one, when I apply force here, when I apply force, any force, when I apply, the direction of force of limiting friction is always, you know that when we apply force here, applied force, if you remember the previous lecture, another force comes into play in that direction, in opposite direction. This is called, this is you know, this is called force of friction, but it comes play into the in opposite direction. The maximum value of the limiting friction, suppose मैंने आपको already बताया, suppose if I apply 1 Newton force, it will also create a 1 Newton force. If I apply 2 Newton force, it will also create a 2 Newton force. In previous lecture I have discussed 3 Newton force, it will also develop a 3 Newton force. But there will become the maximum value for which it will not develop any force, so that the body starts rolling over the another body. That maximum value of force of friction, so that it will overcome the applied force, is called limiting. इसको हम limiting friction कहते हैं. मैं आपको कहता हूँ डायरेक्शन ऑफ फोर्स ऑफ लिमिटिंग फ्रिक्शन ऑलवेज अपोज टू द डायरेक्शन ऑफ इन विच द मोशन टेक्स प्लेस. दैट मीन्स अगर अप्लाइड फोर्स यहाँ से होता है, अप्लाइड फोर्स अप्लाई इन दिस डायरेक्शन, द लिमिटिंग फोर्स ऑलवेज टेक्स प्लेस इन द अपोजिट डायरेक्शन. दिस इज द फर्स्ट लॉ. द डायरेक्शन ऑफ फोर्स ऑफ लिमिटिंग फ्रिक्शन इज ऑलवेज अपोज टू द डायरेक्शन इन विच द मोशन टेक्स प्लेस. दैट मीन्स डायरेक्शन, पहला लॉ है, डायरेक्शन ऑफ द फोर्स ऑफ limiting friction is always opposed to that of applied force, applied force. I hope you have got this is the first law. That means applied force अगर इस direction से, force of friction will take place in this direction. This is also called a limiting friction. I have discussed in first class all about this. Number two, the friction depends upon the nature of the material, surface roughness. जितनी roughness होगी, suppose अगर ये smooth होंगे ये surface, friction depends, that means frictional force कम होगा. जितना ये रफ होगा, जितनी सरफेस रफ होगी, जितना एरिया ऑफ कंटैक्ट रफ होगा एक सरफेस और दूसरे सरफेस को, दैट मीन्स इतना फ्रिक्शनल फोर्स ज़्यादा होगा. दैट मीन्स इट डिपेंड्स अपॉन द नेचर ऑफ द सरफेस. वो फ्रिक्शनल, यू दिस इज कॉमन सेंस, फ्रिक्शन डिपेंड्स अपॉन द नेचर ऑफ द मटीरियल या रफनेस. दैट नेचर ऑफ मटीरियल मीन्स इट डिपेंड्स अपॉन द रफनेस ऑफ द सरफेस. दैट मीन्स फ्रिक्शन, this is second law. Friction depends upon the nature of surface. Number third law, when we move to about the third, this does not, the frictional force, this limiting force, this limiting friction does not depend upon the area of surface. इसका ये मतलब हो गया जो limiting, suppose this is the area of surface, I have put here a calculator on this is the area of surface. The जितना में अगर मुझे 5 न्यूटन फोर्स अप्लाई करनी पड़ेगी, इसको लाने में 5 न्यूटन फोर्स अप्लाई करना, इफ आई पुट इन दिस डायरेक्शन हियर, इसमें कम एरिया ऑफ कंटैक्ट अब कम होता है. इसमें भी अगर इसमें 4 न्यूटन फोर्स अप्लाई हो जाएगा ताकि रोल हो जाएगा इस सरफेस पे, यहाँ से भी मुझे 4 न्यूटन ही फोर्स अप्लाई करना है। दैट मीन्स इसमें एरिया ऑफ कंटैक्ट कम होता है, इसमें एरिया ऑफ कंटैक्ट ज़्यादा होता है। दैट मीन्स यहाँ भी मुझे 4 न्यूटन फोर्स अप्लाई करना पड़ता है, यहाँ भी मुझे 4 न्यूटन फोर्स अप्लाई करना है। दैट मीन्स it has been shown practically that it does not depend upon the area of the surface. It does not depend upon the force of friction is independent of apparent area, that it does not depend upon the area of the surface. Number third law, that means it does not, I hope you have got, it does not depend upon the area of surface. I hope you have got it. It does not depend upon the area of the surface. ये area of surface. अगर that means if I have to apply 4 Newton of force so that it can roll over the surface of another body, अगर मैं इस कैलकुलेटर को इस डायरेक्शन में लूँगा, दैट मीन्स एरिया ऑफ कंटैक्ट स्मॉल होगा, इसमें भी 4 न्यूटन फोर्स अप्लाई हो जाएगा। अगर मैं ऐसे रखूँगा, एरिया ऑफ कंटैक्ट ज़्यादा है, इसमें इट हैज़ बीन शोन एक्सपेरिमेंटली प्रैक्टिकली, इसमें भी 4 न्यूटन मुझे फोर्स अप्लाई। दैट मीन्स इट डज नॉट डिपेंड अपॉन द एरिया ऑफ द कंटैक्ट। हाँ, it depends upon the normal reaction. It depends upon the normal reaction. It depends upon the weight, that the magnitude of limiting force is directly proportional to the normal reaction. Normal reaction को अगर यहाँ मैं अप्लाई कर रहा हूँ, इसका वेट वही रह जाएगा। अगर ऐसे भी अप्लाई करूँगा, इसमें वेट ऐसे ही रह जाएगा। अगर मैं ऐसी सूरत में इसको इस पर डाल दूँगा, इसका वेट वही रह जाएगा। दैट मीन्स it depends upon the normal reaction. It depends upon the normal reaction. Normal reaction means it is directly proportional to the weight of body. That means if it depends upon fourth law. I hope you have it depends upon the normal reaction. This is the fourth law. It depends upon the normal reaction. If I write in the mathematical way, that means force of friction, which it is called static friction or limiting friction. Limiting friction is the also the static, is the maximum value of the static, which is depend upon the normal reaction. Normal reaction means weight. Or if I put here FR, L, FR is the force of friction, L is the limiting friction. Limiting friction, you know, in previous class I have discussed it. अगर थोड़ा बहुत मैं आपको बताऊंगा, ग्राफ बताऊंगा। अगर ये अप्लाइड फोर्स है, ये फोर्स ऑफ फ्रिक्शन है, अगर आपको पता है, याद होगा फोर्स ऑफ फ्रिक्शन, मैंने पहले आपको बताया ये ग्राफ, अगर आपको याद होगा, फिर ये डाउन होता है ऐसे, फिर ये दिस एरिया इज द लिमिटिंग फ्रिक्शन, दिस या स्टैटिक फ्रिक्शन इसको कहते हैं। दिस एरिया, दिस स्मॉल पोर्शन इज द लिमिटिंग फ्रिक्शन, दिस इज द स्टैटिक फ्रिक्शन, दिस होल इज कॉल्ड स्टैटिक फ्रिक्शन, दिस काइनेटिक फ्रिक्शन। आई हैव डिस्कस्ड दिस curve in detail in the previous class. That means force of friction is directly proportional to R, or we can write mu R, but this mu, it is called coefficient of friction, is the coefficient of limiting friction here. Mu L मैं आपको बताऊंगा, या we can say mu L, या mu L is called FRL divided by R. That means it is called coefficient of friction. Yeah, we can say coefficient of static friction, or simply we can say coefficient of limiting friction. This is all about the laws of the friction. That means we have studied various laws. What is the law? Normal reaction के बारे में आपने पढ़ा। फर्स्ट लॉ है डायरेक्शन of the force of limiting friction is always opposite. अगर applied force यहाँ हो, limiting force of friction is direction में, that means force of friction will develop in that opposite direction. It depends upon the roughness. The frictional force depends upon the roughness of the surface, the nature of the surface. Nature of the surface means it depends upon the roughness, where the surface is smooth or rough. That means I have to apply so much amount of force, and so that equal amount of this frictional force will be developed in opposite direction. It does not depend upon the area of the surface. मैंने आपको बताया area of surface पे क्यों नहीं depend करता है। If I take two bodies here, one is notebook here, one is calculator. Here the area of contact is very small, here area of contact is large, here area of contact is small. अगर इस डायरेक्शन में मैं रखूँगा, अगर मुझे रोल करना है, मुझे यहाँ भी वही सेम अमाउंट ऑफ फोर्स आई हैव टू अप्लाई। सपोज अगर मुझे 4 न्यूटन अप्लाई करना पड़ेगा इसको रोल करने में, यहाँ मैंने भी देखा, यहाँ 4 न्यूटन फोर्स अप्लाई करना है ताकि ये रोल हो जाए। अगर इस डायरेक्शन में भी रखूँगा इसको भी, मुझे 4 न्यूटन ही फोर्स अप्लाई करना पड़ेगा ताकि ये बॉडी रोल हो जाएगा। दैट मीन्स इट डज नॉट डिपेंड अपॉन द एरिया ऑफ द कंटैक्ट, इट डिपेंड्स अपॉन द नॉर्मल डायरेक्शन वेट। अगर मैं इस डायरेक्शन में भी इसको रखूँगा इसका वेट वही आ जाएगा, अगर इस डायरेक्शन में देखो इसका वेट वही आ जाएगा, अगर इस डायरेक्शन में रखूँगा इसका, दैट मीन्स इट इज डायरेक्टली प्रोपोर्शनल, द फोर्स ऑफ फ्रिक्शन डिपेंड्स अपॉन द नॉर्मल डायरेक्शन और weight. You know that this is called a normal direction weight. Mathematically we write Fr is directly to R, Fr is equal to mu R, mu L R, mu L is equal to Fr divided by, we have to calculate the coefficient of static friction or we have to calculate the coefficient of limiting friction. ये किसके बराबर होता है? Inshallah we will do it in the next class. We have to calculate the value of this mu R and we have to discuss also the this kinetic friction. Inshallah we will do these both cases in the next class. Hope. Thank you very much. Inshallah we meet in the next class.